Hello, good evening to all our viewers, and welcome to Space Oddities, the channel where amateur and professional astronomers meet up every Monday evening to discuss everything about space and beyond. Thank you so much for being with us tonight. My name is Bernard, and I'll be your host this evening. And we have this illustrious panel with us tonight: Andy, Michael, Roger, Larry, and Lou. Good. Hello, everyone. Oddities, the channel where amateur
Greetings, Sir
and
Bernard.
hello. I'm getting echo in the background. Is that normal? Thank you so much for being with us tonight. My name is Bernard, and I'll be your host.
Sounds like someone has YouTube
Everybody,
open at the same
YouTube
time
running.
with the volume on.
Yeah. While our panel is trying to sort this background echo, how's everyone doing tonight?
Fine. Well,
Peachy.
I've had flu since Friday, so not feeling 100%. It's going around Aberdeen like wildfire, but
Yeah,
I'm feeling a bit better today, a bit brighter.
Yeah, good to hear that you're recovering there, Andy. That's great. Yeah. Well, this is I don't know about you guys, but I'm hearing this echo in the background, and it's it's really difficult to concentrate. Have we all switched off our YouTube channels?
Definitely.
Yeah.
Must be something on YouTube.
Oh, okay. Anyway, thank you very much for being with us tonight. We are so excited tonight because we're going to be discussing about organics on Mars. We're going to be talking about. Have we all switched off our YouTube channels? Around. And hopefully, by the time we move on, we will be able to switch off this. Oh, fantastic! Something happened, and we don't have that sound anymore.
It's gone.
Guys, this is the joys of being live, and sometimes these things don't happen. Sometimes things just don't work
Those
the
are
way they
just
want.
alien transmissions. Ignore them.
There we go. Yeah. So, folks, if you're watching us, we're going live on YouTube. So don't forget to subscribe and like and comment. It will do as usual. And we're also streaming live on Facebook, on Ireland Astronomy, and on our Space Oddities channel. So we're so excited to have you with us tonight. And I guess we're going to start with the usual running order, which is Roger. Roger, what do you have for the night? What do you have for us regarding the night sky?
Well, we've got the usual what's in the weekly night sky, plus a few little updates from the JWST.
Fantastic.
Okay, so here we go for the presentation for 28th of November to the 4th of December. How close are we now to the end of 2022 already? Right, okay, so providing there's any clear skies this week, you'll be able to see a first quarter during the middle part of the week, heading towards the waxing gibbous and new moon later on next week. So, and as you can see, I've got the night sky for the 10 p.m. GMT here, and as you can see, Orion is now gradually obtaining its dominance in the eastern skies at the moment. Jupiter is still well positioned, although it is now on its way over to the west now. Saturn is almost completely gone, but Mars is now taking dominance in the night sky, which is good because we've got the opposition coming up during next week, and more on that later on in the program. Okay, so as you can see, more and more altitude for Mars and Orion arriving, and more of the other winter constellations now. And the weather certainly has gradually dropped down. Now, we've also got some information on WASP 39b from the JWST, and here we have some graphs from the various sensors on the James Webb regarding what it's managed to pick up from its observations. And as you can see, I will put that on to the next slide, as you can see a closer detail. This is an artist's impression, obviously. But James Webb isn't that good. So, okay, so here we have some interesting pickups from one of the slitless spectroscopy near infrared camera, which is picking up potassium, water, carbon monoxide, and other elements of water through that brief slit of wavelength that it's picked up. And if I move further over into the spectrum, we've got more wavelengths of picking up with more water in the atmosphere. But more interesting, we've also got sulfur dioxide, carbon dioxide, and carbon monoxide further on into the spectrum.
I was going to say that potassium's a bit strange, though, isn't it?
Well,
not seen that before.
No, well, we're going to find a lot of things that we doesn't make sense yet, but obviously as time goes on, we'll understand the reasons behind it. But as of yet, these are the initial findings from what we have of WASP 39b.
Bit of a hellhole, really.
Yes.
And as a reminder to our viewers, 39b is like a gas giant. It's as big as Saturn. So it's not yet a terrestrial planet atmosphere, such as like the TRAPPIST planets that were JWST able to pick up these traces in the atmosphere.
Yeah. So 39b will be the innermost of the planets on that system.
That's right. Because the star itself is A, isn't it? And then the next planet is B and C and so on. Yeah.
Okay.
I was going to say, for those of you who might have known that the Webb recently imaged the TRAPPIST system, this incredible system of 7 planets, at least 3 of which appear to be in the habitable zone. The scientists have a proprietary right to the data for 1 year. So it could be a year before they release the results of that. But that's how it works. That's how the system works. So it might be a year before we find out exactly what the Webb found in the TRAPPIST system, which is probably one of, if not the best system yet, where we think life might exist of all the exoplanets that have been found. But I'm sure that if they find anything really revolutionary, I'm sure they'll want to get it out before the year is out. But theoretically, they could wait a year before releasing the data for the TRAPPIST system.
And when they find these unique elements in the atmospheres, that's the beginning of the work, right? Because then you get your theorists, your photochemists, your dynamicists together, and they have to come up with a model for why it's there. So we should be seeing lots of papers from the modelers, I suspect, in the near future.
Absolutely. I mean, with all of this data, it's barely started, and it's the beginning of a process, not the end.
So with sulfur dioxide and carbon dioxide, will there be some volcanic activity down on the surface?
Not with a gas giant.
Oh, no, I suppose not.
Gas giants as we know them, I guess. Yeah.
Gas giants as we know them. Absolutely. But
a volcanic core.
But for massive planets, you're going to have lots of meteoric activity, right? You're being drawn in. So who knows? Who knows what sources?
And there might also be satellites like Io, which are venting out loads amount of sulfur.
Right.
Although, of course, this is the planet's atmosphere, but maybe it might contaminate the atmosphere as well. Who knows?
Well, I think we have enough to write our own paper, guys. Right here. Let's make it happen.
Absolutely. Io certainly contaminates Jupiter's atmosphere, doesn't it? So
the Io Taurus.
Yes, the Io Taurus
through Jupiter's magnetic field. Yeah.
Yeah, absolutely. There's a really I forget what it's called, but there's a fantastic video about the Io torus on YouTube somewhere, explaining exactly how it works. There we are. That's great, Roger.
Okay.
Thank you.
I've just got this last slide. This is obviously most people's favourite constellation, which is Orion. And I posted it up on Facebook, and it's gone down a bit of a storm.
That's lovely.
Obviously, with a bit of haze that went across the night sky, it just glowed the major stars up rather. So I just copied that over and highlighted the major formations and also enhanced the colours up rather, and that's pleased a lot of people.
There's no mistaking Betelgeuse there, is there?
No. Excellent, Roger.
That's superb, Roger. Well done.
Yeah. So on one of the groups, I've had about 1,700 likes for that. So,
wow.
So it's obviously pleased a lot of people. So I thought perhaps I ought to try and do something similar with all the other 87 constellations.
A thin cloud really does bring out star colour sometimes.
It brought it out amazingly much more. Yes.
Amazing, isn't it? Absolutely amazing.
I don't think quite, if you defocus it slightly, it's not quite as effective as the cloud had managed to produce. But there we go.
Lovely. It's absolutely lovely. Right. Thank you, Roger. Thank you very much, as always.
Thank you so much, Roger. That was great, and I really love that image of Orion. I mean, the joy of winter in the northern hemisphere and being able to start to see all these wonderful constellations. That's great.
Sorry, before I forget, unfortunately, viewers, there won't be a viewers gallery this week because Rachel couldn't join us tonight. So the images that you had submitted for this week will, of course, be held over to next week, and thank you for that.
Yes, and also, if you are from the southern hemisphere, please do let us know, because we're conscious that we're currently very northern hemisphere centric, but we do want to cater for all our viewers. So if you also want to see the southern hemisphere night sky, what's up, Roger will more than happily do that. Isn't that correct, Roger?
Absolutely.
Great. Cool. Thank you. Well, thank you for that. We're going to move on now to space news with Michael. What do you have for us, Michael?
Thank you, Bernard. Just bear with me. I'll just share my screen. You got that?
Yeah, there we are. There you go.
Okay, so space news. Main news this week was last Wednesday. ESA introduced their new astronaut selection for 2022. 17 new people from around Europe were selected to join the astronaut corps for Europe, and these are the different names of the people. There's 5 career astronauts who will start training for missions straight away, and 11 reserve. And one of those reserve astronauts has got a physical disability, and that was one of the wish lists on the wish list for ESA's new astronauts, that they want to encourage people with a disability to apply. And that's what's happened there.
Michael.
Yeah.
Sorry to interrupt you. Are we supposed to see the faces of the candidates? We're only seeing the presentation page at the moment.
You're not. Hang on. Let me advance it manually for you, Michael. Again.
Okay. Sorry, I thought I'm sharing my screen, wasn't I?
Oh,
yeah. No,
those are nice pictures.
Yeah.
No, we've only now seen the picture, Michael, of all the selected astronauts.
Oh, okay. So if you go and advance one more, and then okay. So these are all the names of the new astronauts, and you'll see the member states from which they're from in that table there. For the people in the UK, we have 3 people from the UK joining the astronaut corps, and one of those is John McFall, who's actually down as a para-astronaut. He is a disabled person who had a motorcycle accident and had to have a leg amputated, and he had a new limb given to him, and he had to learn to walk again, and walk and run. And I'll talk about more on that in a minute. So the first one I'd like to introduce you to is Rosemary Coogan, who was born in 1991 in Northern Ireland. If you want to go to the next slide, Andy. Yeah. This is Rosemary. She holds 2 master's degrees from the University of Durham in the UK, and she completed an undergraduate master's degree in physics in 2013, which focused on physics, mathematics, computer programming, and astronomy. And in 2015, she received her master's degree in astronomy, where she conducted research on gamma ray emissions from black hole. In 2019, Rosemary graduated with a doctorate in astronomy from the University of Sussex, and spent 1 year as a visiting scientist in Paris, and 2 weeks as a visiting astronomer in a Hawaiian observatory. She also speaks English, French, and basic German, which is one of the requirements of becoming an ESA astronaut. Is you must be able to speak at least base speech for 2 other European languages. Okay. The next one is Megan Christian, born in 1987 to British. She has a British and Italian citizenship, but she was actually born in Australia, and she holds Australian and New Zealand citizenship. And she will be representing the UK. She studied at the University of New South Wales in Sydney, Australia, and graduated in 2009 with a Bachelor of Engineering in Industrial Chemistry, receiving a final grade of Class 1 honours. And during her studies, she undertook several internships at chemical industries, where she worked in optimising and troubleshooting water treatment processes.
Wow.
Quite good for her. And also another one good in languages. She's fluent in English, Italian, and French, but also speaks some Japanese as well, which will be good for the Japanese involvement in the ISS, for instance, and the Gateway. This is John McFall, born on 25th of April 1991, and she was completed his bachelor's degree in Swansea in 2004. And in 2014, he graduated with a Bachelor of Medicine and Surgery from Cardiff University. Following a motorcycle accident which resulted in the amputation of his right leg at the age of 19, John learned to run again. He became a professional track and field athlete in 2005, going on to represent Great Britain and Northern Ireland as a Paralympic sprinter. Okay, and John also sat on the UK Athletics Athlete Council, where he was for 4 fellow athletes on the World Class Podium Programme. So those are the 3 really to look out for in the coming months and years for ESA astronauts.
Has there been much coverage of John McFall in the British press?
Not that I've noticed.
That's a bit sad, isn't it?
Yeah. Okay, on to Artemis program now. On Saturday, the Orion spacecraft surpassed the distance record for a mission with a spacecraft designed to carry humans in deep space and back to Earth. The original record was set on Apollo 13 in 1970 at 248,000 miles. And tonight, Monday, 28th of November, Orion reaches the midpoint of its mission and its farthest distance from Earth when it is nearly 270,000 miles from Earth. That's a nice picture taken on flight day 11 from one of the cameras on the solar panels, looking back at Orion capsule and the Earth in the background. Rather nice image, that one. So
the mission seems to be going very well at the moment, although a few days ago they lost contact with Artemis for 47 minutes for some peculiar reason.
Yeah.
And it just came back.
just came back. One thing I haven't put in here, which I will mention now, one of the things that's been mentioned in the last few days, which NASA didn't mention straight away, after the launch on the 16th, when they inspected the launch tower, they found a lot of damage to the launch structure, the launch tower, and the infrastructure inside the launch tower. One of the pictures I saw was of the lift doors where the astronauts are taken up to the top of the tower were actually blown away from the force of the rocket engines on takeoff. So there's a lot of work to be done on the launch tower before the next mission. Okay, as I say, tonight is the 270,000 miles from Earth. And also tonight, those who are interested, at 10 p.m, there's a status briefing at nasa.gov on the status of the mission so far. So that could be worth having a look at later. Just some SpaceX news now. On Wednesday, Eutelsat 10B was launched from the Space Launch Complex 40 at Cape Canaveral. This was the 11th and final launch of this booster, which previously supported the launch of Telstar 18, Vantage, Iridium 8, and 9 Starlink missions. The reason for this is that because Eutelsat 10B was going into a geostationary orbit, the engines had to be burned for a lot longer to get to the required altitude for the transfer. So there was no way that the booster could be recovered because of that. But following that, on Saturday, we had a brand new booster take off, this time at Launch Complex 39A, which was the CRS-26 mission, the commercial resupply services to the ISS, and that was a brand new Falcon 9 rocket plus a brand new Dragon spacecraft for the cargo services. And Dragon autonomously docked with ISS on Saturday the 27th at 12:30 GMT. So it's brand new spacecraft and brand new booster. Nice to see it in gleaming white.
Yeah, indeed.
And just as a final slide, just to let you know, following the docking of the Dragon, we have 2 Dragons on the ISS, the Crew 5 Dragon and the CRS-26 Cargo Dragon. We have 2 Progress spacecraft, Progress 81 and 82. A Soyuz MS-22 and the Cygnus 18, which totals 6 visiting spacecraft to the ISS. So quite complexity there on the ISS at the moment. And that's all I have this week.
Great, thank you very much, Michael.
Okay.
Did you guys see the Earth-Moon eclipse picture from Artemis today? It was released just a short while ago.
No, I missed that one. I'll have to have a look at that one then.
Can we have it uploaded at some point?
I'll see if I can find it. Okay. I'll try to find the pictures and share them.
When we were doing our coverage of the orbit correction burn last week, we saw live the Earth touching the horizon of the Moon and the second behind it. And just as it did that, they lost the telemetry as Artemis went behind the Moon. But it was lovely watching the Earth slowly sinking towards the limb of the Moon. It was just, and to realise you were looking at it live, it was just unbelievable.
Yeah. And the other image I've seen today is when Artemis was quite a long way away from the Moon, looking back at the Moon, and it had the Earth in the distance as well. So you had the almost half the Moon and half Earth in the same image.
Cool.
Okay.
Thank you so much, Michael, for the news. I don't know about you guys. I don't think I'm going to look at any other biography of any other ESA astronaut for now, because it's just these people are like superhuman, with degrees and everything, and I'm like, oh gosh.
But you would think that a disabled British astronaut, the first, would be all over the front pages of the news in an ideal world, but not to be.
And Dune on Facebook, sorry, on the YouTube comment said she saw him on the Channel 4 News.
Oh, right, okay, good.
So it seems like it was picked up at some point.
Yeah, and of course the reservist astronauts will receive basic training, but they will go back to their usual jobs at the moment until a mission can be identified for them. So, yeah.
Really cool. Great. Yeah. Thank you so much, Michael. Okay. Let's move on to Andy. I think Andy would like to talk to us a little bit more about the benefits of space exploration.
What we thought we would do, as you may be aware, viewers, we've been discussing over several weeks the benefits that space exploration has brought to humans, and I hope we've made the very convincing case that it brings innumerable benefits. But what we thought we'd do today, just to round that off, is just to sort of have a brief chat about all of that. Does anybody have any general thoughts about the benefits of space exploration? Lou, you've obviously got a NASA perspective on this. What's your perspective?
Well, in a way, I think it doesn't really matter.
You think it doesn't really matter?
We've been exploring the Earth, the atmosphere, and then later on space, probably as far back as we have records. It's just something that we do. It's part of being human. And so if you're trying to make a solid case for the technology benefits and benefits to humankind, I think you can do that, and I think we have. But it is inevitable that we will explore. We will explore the space around us to the planets and perhaps someday beyond. At least as far as a motivation, I think we're just going to keep exploring.
Yeah,
so that's kind of my thought.
And I also think that there are some examples from histories of cultures that didn't have that curiosity, that urge to go beyond the next horizon, and those cultures failed. If you look at the ancient Polynesians spreading out across the Pacific and how they enriched the human condition with everywhere that they got to, like Hawaii, they really did have this desire to know what was out there, and I think cultures that don't get very, very introspective, and I think that's dangerous. And I think in some ways we're in danger of becoming like that. That we're doing too much navel gazing these days instead of looking outwards. We should be looking outwards more instead of inwards. That's just my opinion, but I think history is filled with examples of cultures that failed because they didn't wonder what was over the next horizon, and they didn't want to know, and they didn't want to explore, and they didn't want to learn. So that's my perspective. Anybody else got any other perspectives?
I'd like to mention that I really resonate with Lou's message. I might just add that it might be American-centric because of the American culture. Let's not forget that the Chinese culture, China in the 14th and 15th century stopped their exploration and mothballed their ships and everything else, and sort of turned back on themselves inwards, even though they had this massive exploration program, the exploration of the oceans at the time. So this thirst and push for exploration and going beyond is definitely within us. But sometimes there are moments where this is curtailed. So I wouldn't be as optimistic as to say it's guaranteed we're always going to explore, and I'm I'm not, of course, going against what Luce just said. I'm just saying that sometimes there might be other things that might prevent this from occurring.
Yeah, absolutely.
I think that exploring, and like we just saw there with looking at the atmosphere of an exoplanet, there are questions that we don't know to ask until we find the next thing. And it's just a constant chain of new questions every time you find one new thing. And that is so exciting. And I can't imagine having a mindset where that doesn't excite you.
No, that's right. Absolutely.
I'd like to say about the benefits, direct benefits, if you like, to us all. Like everybody these days has use of the benefits of space technology. You've only got to see the number of people with mobile phones, with sat navs in the car, and sat navs in the mobile phones. It's all come from research into space technology. It's a direct benefit. Even things, a lot of machinery that we use in the home, like kitchen appliances, like microwave ovens, that sort of thing. Virtually everybody has got them, and that is a direct benefit. And of course, every day we look at the weather on the TV. How is that forecast made up? Not just the sensors on the ground, but the weather satellites in space. It's all come from space technology, and I think a lot of people just take everything like that for granted now, without a thought of where the technology came from.
Have you guys been watching that new Hannah Fry thing that's on BBC at the moment? It's where she takes apart an everyday item that we just take for granted and kind of shows how it works. And the number of people that complain about waste of money on space exploration are doing it on a phone and have probably ordered a delivery for their dinner that weekend.
Yeah.
None of those things would exist if it wasn't for the space industry.
Exactly.
Not to mention the medical benefits as well.
Oh, yeah.
I mean, anything that has been shrunk into a small footprint, like MRI scanners, etc., had done so because they need to fit on a spacecraft with limited space. And we get the direct benefit from that, and we just wouldn't have it if it wasn't for the space industry.
Absolutely. Yeah. So that's it then. Any other points before we move on?
I just want to reiterate again that let's not forget that space agencies and space explorations are actually funded by politicians, and politicians needs the support of the public in order to ensure that we have the right amount of budgets to do these. So if you do want to see us carry on exploring, you do need to support your politicians and to message them and to incite them to continue on, supporting space agencies and space missions. That's the only way it will happen.
and of course, we'll pay for it in our taxes.
Yeah.
Yeah.
But of course, it's coincidental you should mention that, Bernard, because of course the European Space Agency has just seen a massive increase in budget, its biggest on record. Europe has given the European Space Agency. Can you remember the figures, Michael, or what the percentage was?
No.
It was something like a 15% increase over the previous year. If I'm right, I can't remember the exact figure, but it shows Europe's confidence in the space industry and the benefits of it. So if that's not a demonstration of the benefits of space exploration, I don't know what is.
One of the things I remember from it, though, there's a possibility that the Rosalind Franklin rover, which was cancelled because of it was going on a Soyuz rocket originally, that could be adapted to go on to a European launcher instead. So that could be saved in the end, which is good.
Absolutely. Would that be the Ariane 6, presumably?
I would think so, yes. I haven't got all the details yet.
Makes sense.
And in terms of budget, and I know I rang this bell maybe too often. I fully support human space exploration. I'm excited about the Artemis program and having a continual presence on the moon, and as NASA says, moon, Mars, and beyond. But it is also true that in terms of our understanding of the universe, including creating new technologies that we never thought of before, James Webb, for example, they had to create many new technologies, Parker Solar Probe, new technologies just to build these things. Is robotic exploration is you get a much bigger bang for your buck in terms of knowledge return. So when we see large increases in budgets for NASA, for ESA, for JAXA, for other space programs, keep in mind that a lot of that is for human space exploration, which is much higher risk, much more difficult to do, and therefore more expensive. So I guess I kind of support a balanced program of robotic and human exploration.
Absolutely. And I was watching an interesting video on YouTube about the successor to the James Webb. Well, it's not a direct successor. The plan is, and it's only a plan at the moment, it's nothing formal yet, to create a new telescope called the Carl Sagan telescope, to be launched on the 100th anniversary of his birth in 2034. And this will be an optical telescope, twice the size of the Webb. And the idea is to directly image the atmospheres of exoplanets with it, which it should be able to do with a mirror that size. So, this is exactly what you just said, Lou. The benefits, the scientific benefits from that could be absolutely enormous. So there we are. Okay,
that's great, and I'd like to add a little controversial point to what Lou just said. If you would take the budget of the ISS and just move it across to the robotic space exploration, we would have discovered most likely, what is venting off of the moons of Enceladus and Europa. We would have explored all the moons of our solar system. We would have explored Neptune, Uranus. We would have done so much more in robotic exploration. And probably gained much more insight. So I'm more in favor of sending robots than humans, but that's just my point of view.
And I absolutely agree with you, Bernard. I often say that just a little differently. For the price of one aircraft carrier, we could have burrowing down through the soil at this. So it's just all a matter of priorities and what the public, I think, wants to do with their tax dollars.
And just to finish off space benefits, I think we need to put the whole thing in perspective. And there was, of course, a man with an unnatural gift for putting things in perspective, and that was Carl Sagan. So I thought just a couple of minutes, we'll just finish with his famous speech, The Pale Blue Dot. Here we go.
Mm-hmm.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
The late great Carl Sagan, of course, with Pale Blue Dot, which says it all, really, doesn't it? I mean, you can't sum it up better than that. Wow!
Stunning.
Absolutely. For those that for our viewers, no, we have not stopped the show. The show is continuing. We've had some comments about that. Thank you so much, Andy, for sort of closing the benefits of space exploration.
Well, I thought it was important to put things in a sort of a cosmic perspective.
Absolutely.
And you know, while it may make us feel incomprehensibly tiny in the universe, I think it also at the same time makes us feel incomprehensibly powerful as well, because of our very existence. And that is something that we should always remember, that we are extremely lucky to be here at all, and we should never lose sight of that.
Agree. Any other thoughts, panelists?
Kind of hard to follow Carl Sagan.
Yeah.
All I can say is what he said.
You can imagine being on a lecture tour, can't you, and being told you've got to come on after Carl Sagan. Damn.
Carl Sagan, the warm-up act.
Yeah, that's right. Carl Sagan's warm-up act.
Right. Well, thank you so much, Andy. Before we move to the next presentation, I'd like to mention the fact that Anne Dune talks in the comments about a great book on Hawaii to discuss about the way they got stuck on the Polynesians got stuck on the Hawaiian island. And Astronebuli says that there's an interesting program on JWST on Horizon on Saturday. And Mary's managed to find the picture that you were mentioning earlier on about the Artemis Moon-Earth occultation. Would you like to show it to us? There we go.
Yeah.
Go back to the first one.
That's brilliant.
Thanks to Stu Atkinson for these. I just stole them blatantly from his Facebook page.
Yeah. That's great, isn't
Amazing.
it? And then this one's amazing. Look at that.
It's another angle on dynamic astronomy.
Yeah, definitely. And it shows just how far beyond the moon Artemis is, doesn't it?
Yeah.
You get a real
I mean,
sense of.
and I think a lot of people that don't appreciate that the Earth has phases as well as the moon. You know, I know we see the sunrise and the sunset, but do people realise that the Earth goes through phases? If you look at it from the moon, for instance, you know.
Yes, indeed.
Usually the opposite of what we can see on the moon, isn't it?
Yeah,
If I remember
that's
correctly.
right. Yeah.
We have seen images similar to this before from the Discover spacecraft, which I believe is located out at the L1 position.
Right.
And for the 2017 eclipse, we showed images of the moon. Of course, the moon appearing smaller with respect to the Earth in that orientation, moving in front of the Earth. But these are stunning images nonetheless.
They are, aren't they? Absolutely brilliant. And wasn't it a fantastic idea to locate the camera on the solar panels?
Yeah.
so that the camera can actually change its position, which is great.
I wondered who was out there taking those pictures. I thought this was an uncrewed mission.
Yeah, it's don't tell anybody. It's one of the Moonikins has come to life thanks to cosmic gamma rays. So there we are.
Right. And they sure know where to put the NASA logo on the spacecraft.
There's no doubt it's spacecraft, it is.
Yeah. All right.
No,
thank you very much for that, Mary. That's just I bore everyone when I say this, but we just live in extraordinary times.
Yeah, we do.
Let's go to discuss about Mars opposition. Lou and Roger.
Wow, great. Thanks. Coming on after Carl Sagan. That's terrific. What to do?
Blame Andy.
Would you like me to do my M87 thing first, if you want to organise yourself, so that I can follow Carl Sagan? I think you need to follow Carl Sagan with a black hole. Really, it's the only thing that can equal it.
Well, be my guest.
Okay. All right. Okay. So, interesting news about the M87 black hole. Now, you may well remember this image from 2019. It's the famous image of the black hole in the galaxy M87. And there's been quite an interesting new discovery I want to tell you about. They're always making new discoveries from this data, of course. The most recent major one was that a lot of the light in this image, the radio light, is polarized, which has enabled them to map the magnetic field of the black hole. But this is something new. Let me tell you all about it. So this is the famous image, as we know. And the thing about it is that, just give me 1 second to sort myself out here. My monitor seems to have gone off for some reason. Okay, just give me a second. So this is all about the black area in the middle of the black hole. Now, the black area in the middle of this image is known as the black hole shadow, and I would like to explain to you what this is all about, because this discovery really concerns this. So this is a dark area. It was widely reported in the media at the time that this is the event horizon of the black hole. It isn't. The actual black hole is within that dark area. It's probably about a fifth or a sixth the size of that dark area, but because it's black, funnily enough, we can't see it. So what is this black hole shadow? Well, first of all, it's enormous. If you look at the size of this, that's the size of it. You see the orbit of Pluto there and the current location of Voyager 1. So this is an enormous structure. And how does it happen? What is the black hole shadow? Well, let's have a look. So this is all to do really with gravitational lensing, which we've talked about a lot in recent weeks with regards to the James Webb Space Telescope images. And so let's have a look at how that actually works. Now, first of all, you have photons that approach the black hole and are bent around the black hole by the immense gravitational field. to be absolutely accurate about it, the photons travel in a straight line because they can't do anything else. But the space-time they are traveling through is curved thanks to the immense gravity. So they do, in fact, describe a curved trajectory. And what happens is that all those photons coming from whatever angle, they end up following parallel paths because they have been diverted in their trajectories by the gravity of the black hole. And as a result, this is what we see from the Earth. We see an area of black where there are no photons, a completely dark area, because the photons have all been diverted around this area. So the central bit of the famous black hole image is completely dark. Now, we knew this already, but it's slightly more complicated than that, because there's something about the way that each photon approaches the black hole that has another effect. So what do I mean by this? So let's take a photon, as we just saw, whose trajectory is just a little bit diverted by the gravity of the black hole. In other words, it's not passing so close to the black hole that its trajectory becomes completely changed. It's only diverted a little bit. So here comes our photon and another, and they are just slightly deviated from their path by the gravity of the black hole. And if we put some more photons in, we can see that what we actually see from the Earth is that sort of structure. This is a bit like a ring, but it looks more like a tornado than a ring. Then we have photons that loop to sort of a half orbit round the black hole and then get diverted to the Earth where we see them, and they create this sort of a ring around the black hole. And then you have photons that describe more complex paths around the black hole. Perhaps they might loop round it once or twice. And then from the Earth, this forms this sort of ring. And these are called photon rings, believe it or not. And if we add in all those different types of photons with their different trajectories, what we should see when we look at the black hole is something that looks like this. Now, this is an extremely important image because it's the history of all the photons that have interacted with the black hole. This can tell us so much about the gravitational field of the black hole, how that works. It tells us a lot about the spin of the black hole. It tells us a lot about the mass of the black hole. So it would be wonderful if we could see these photon rings from the Earth. And in fact, because the trajectories of the photons can be almost infinitely variable, there could well be an infinite number of different photon rings. But when we look at the black hole image taken by the Event Horizon Telescope in 2019, we don't see the photon rings. All we see is this, which actually now I've put it in there, looks more like a donut than a black hole. However, this is what we see. Why don't we see the individual photon rings, which would help us learn so much about the black hole? The reason is very simple. The Event Horizon Telescope yet does not have the resolution to distinguish those photon rings. It may well do in the future as more telescopes are added to the array, the technology improves, we start putting radio telescopes in space to be part of the array, the resolution will get finer and finer and finer, and we may be able to directly observe these photon rings around black holes, but we cannot at the moment. We just sort of end up with this amorphous blob of plasma at radio wavelengths, and we don't get to see the photon rings. That is until now, because a team of scientists have come up with this. Now, what they managed to do was subtract all of that glowing plasma from the image, and what they found leapt out at them was what looks very much like a photon ring. And this is quite amazing. So this is the image they've come up with. The wavy lines are an indication of the intensity of radio emissions. Just incidentally, do you see the structure at sort of bottom right, at the 4 o'clock position? There's a definite structure there. That is where one of the jets, the jet that is pointed towards the Earth, is anchored at the black hole. So there's quite a complex radio emission going on there. Now, They say that this structure was stable, the photon ring that is, over the 4 days that the Event Horizon Telescope took to image the black hole. And it's indicative of a photon ring from photons that have described half an orbit around the black hole before being diverted towards us. So this is an important step forward, because if this is true, then it could teach us a lot about the black hole and could leave the scientists able to perhaps extract other photon rings from the image, and we'll see what happens. However, it should be pointed out that this image of a photon ring has not been universally accepted. For example, Dan Maroney of the University of Arizona said, if you want to claim that you've seen a photon ring, I think you have to do a better job than this. He wasn't impressed. Also from Arizona, Sam Greyer from Arizona said the claim of a photon ring detection is preposterous. Now, both of those complaints were based on the fact that they said the photon ring is just too bright. The photon ring should, by the maths, be no more than 20% of the total brightness of the black hole image, and in fact, it's more than 40%. But Avery Broderick, who led the team who produced this image, came back and said, well, actually, some of the light from the radioplasma is incorporated into the photon ring, and that makes it artificially brighter. And they say even in our simulations that happens. So they are absolutely adamant that that's completely normal and sort of expected. So the controversy rages on, and we probably won't know a definitive answer until the technology improves sufficiently to see the photon rings directly. But photon rings are very important for understanding black holes, and we will see what the future holds. So there you are. So I just thought I mentioned that because I was quite excited by that. And it's amazing to me that they're still managing to pull incredible data out of that image. Don't you think, guys?
I think that people in Arizona are just jealous.
I think probably so, yes. What is it about Arizona? It's full of curmudgeons, obviously.
It's amazing. It's amazing. And thanks for showing those visualizations.
Well, if there's any further developments on the black hole image, I will let you know, of course. Right, sorry, Luke, are you raring to go with your Mars opposition now?
Now I'm even more, reflector. That was brilliant. That was very well done, Andy. Thank you.
Thank you.
Are you doing the slides here?
There you go.
Thank you, sir.
Just maximize that for you.
Well, we have a very special time coming up. Every 26 months, a little over 2 years, we have a Mars opposition, which means that Mars is opposite to Earth from the sun, and therefore roughly at its closest place to Earth. And this is an exciting time because it really makes a difference in the size and the ability to see faint markings on Mars. But this happens every 2 years. And as you see from this graphic here, you notice that the orbit of Mars, the purple oval on the outside, is a bit eccentric. Thank you, sir. A bit eccentric. And it is, in fact. The eccentricity of the orbit of Mars is about 0.09, and of the orbit of the Earth is 0.01, where 0, of course, is a perfect circle. So it makes a difference when opposition occurs, whether or not we are close to Mars in its eccentric orbit or far away. And so you can see in this diagram here that we have in 2022 near the top on December 8th. We're not quite near the as close to Mars as we were back in, say, 2018, but still a fairly good opposition. Just to kind of drive this home, this is the motivation for a lot of our Mars missions. Well, for all our Mars missions, they're really impossible to have unless you do it every 2 years, every 26 months or so. And so you just see this is just a representative sample back to 2011 of the Mars missions that have been that have been sent by various countries. And you can see that roughly they are every 2 years in separation, although we didn't have one in 2022. So for this apparition, on December 1st, we're going to have Mars that subtends about 17 arc seconds in size. And you can see how quickly that drops off. On October 2nd, it was 12 arc seconds. And on January 21st, it'll be 12 arc seconds. So this is the progression of how Mars would look in a telescope. It really does look quite a bit larger when it's at its closest point to Earth. And I'll just close this part of the discussion with Mars oppositions historically and into the future. So you can see our 2022 opposition here at 17 arc seconds in size. Back in 2018, you can see what a difference that was, 24 arc seconds. It looked much larger. And then for a while, for the next few cycles, we're going to have a little bit smaller images of Mars. Nevertheless, when this occurs, Mars is much larger than throughout the rest of the 2-year period. So it's a real opportunity to view and to photograph Mars. And with that, I'm going to turn it over to Roger to tell us a little bit about viewing and photographing Mars.
Okay, well, thank you very much, Lou. Okay, right. So this is the equipment I'm currently. It's that one, not that one. Is that?
Oh, sorry, that was me.
Hold on.
Right.
Okay, this is a imaging setup that I've got that I use for my planetary imaging. What you can see there is a Celestron C11 Schmidt-Cassegrain, which has got behind it a atmospheric corrector for low refracting planets, which can be corrected. Then I've got an eyepiece, which is in a flip box, because the magnification is so great, you have such a tiny field of view that it become almost impossible to actually look at it straight away. So you can just fine-tune the position of the telescope to get that through the eyepiece. And once you've got that, you can start imaging it. And what I shall show you are a few images that have been taken during this year of my efforts of the planet Mars. And as you can see, there are various parts of the surface there which you can see. Obviously, with the rotation of Mars being fairly similar to the Earth, you obviously have to look at it at different times during the night to be able to get different facets of the surface. So obviously you have to be rather persistent to make sure that you don't keep seeing the same face every night. So this is my attempt. It's no Damien Peach, but there are some details that you can see here with my efforts. These were all done during this year. So obviously with the opposition getting closer, the moon, the actual diameter will get bigger and bigger. And I'll obviously, once the opposition is over, I'll be doing a sort of a 2022 comparison of how it approaches and leaves the opposition in size imaging. Any questions?
That's great.
These are
Lovely
fantastic.
images, Roger.
Roger, I do have a couple of questions for you. Did you use video photography to add frames together for this?
Okay, so with the native focal length of the 11-inch being 2,800 millimeters, and then using a times 2.5 converter, it's you're talking about 4,000 millimeters of focal length. So with that, you do lose some light with it, but using a small camera, I can get up to 125 frames per second, which is pretty good. You do have to turn the gain up on that quite a way, but when you're capturing about 15,000 frames, each individual frame noise will cancel out through the whole process. And when you finally process it, you can get a lot more detail come out. And as you can see, there are some details which, providing there's no dust storms on the planet, you will be able to have a look at. And there are various programs which you can put the program into, and it will recognize from the data of the video capture the actual features that you are actually showing.
Just a word about dust storms, Roger. They tend to be more frequent when Mars is at perihelion, its closest point to the sun. So the benefit of that, of course, is that Mars looks larger, but we are not near Mars perihelion, so the chances of dust storms obscuring the surface are less than they would otherwise be.
And of course, the left-hand image, which is my most recent, you can see how much of the polar ice cap there is at the moment. So that's quite an interesting thing to see.
Anne in Ireland asks if you were out for hours, Roger.
Well, I do like to take quite a few moments of videos, and obviously with the Earth rotating and Mars rotating, you will over time, although not as drastically as Jupiter, you will see a rotation of the planet. But there are programs which will derotate the pictures so they're all in sync to get the details better, but that's for another program.
So how long did it actually take you to get these images?
Well, I generally do about a dozen 1-minute videos and then put them all together, and then the program will assemble them into a right sequence so they will all overlay in the right position to bring out the details.
Software is getting very clever these days, isn't it?
I know, and a lot of it is free, so yeah, win-win.
Indeed. Great, thank you for that, Roger. That's brilliant.
Okay.
Stunning shots, Roger. Absolutely stunning.
Not bad.
Thanks for that. I'd like to carry on the Mars theme by mentioning some of the latest news with regards to Mars itself and one of our favorite robots in space, which is, of course, Mars Perseverance rover. Andy, would you be able to put that presentation that I've uploaded?
I don't see a presentation there, Bernard.
You don't see a presentation. Oh dear. Let me just check again.
Yeah. Make sure the ones you've uploaded you actually select it. That's it.
Oh, there we go. I've just selected it.
Right,
folks. Yeah. Apologies for this. We're still working out this on this new platform. It's only been 4 weeks now. Yeah, I just wanted to give a quick update on Perseverance because there's been some latest news. And I've actually realized how I completely messed up the name Perseverance rover. I just quickly typed this afternoon, so I do.
We'll forgive you
for the rover as I mangled its name. I'll just quickly move on to the next slide. So, as you recall, the target for Perseverance mission was Jezero crater, which we believe might be the location of an ancient lake. Due to the deltas, and you can see the three main deltas: the Pliva Vallis, Sava Vallis, and the Neretva Vallis. And as we all know, Perseverance landed last year, the beginning of last year, near Neretva Vallis, but it still landed on the crater floor nevertheless. So it spent its first few months. I'll just quickly come back to that. It spent its first few months, as you can see here at the bottom right. This is the the trajectory of the rover throughout the last year. And as you can see, it first spent the first beginning of the mission in the crater floor and not near the delta. And then it took many, many months for it to drive back towards the delta, as you can see here. And it's at the moment, it's getting closer to this crater at the bottom called the Belva crater, and it's starting to see interesting things. Now, the problem is that I always have issues with how the media reports the news about Perseverance rover, and lately. I'll come back to that. Lately, there's been. I'm just skipping through my slides because I had this thought. Lately, you've just found, I just saw this is of course Fox, but it says hints of life. Rover finds potential signs of microbial life on Mars, and that really cringes me a lot because this is this is not really what Perseverance rover has found, and I don't know. I mean, it seems like there has been quite a few news media outlets that have been, flying again the banner of life on Mars and such. Let's just go back and quickly remind ourselves: the Perseverance rover has amazing instruments, and it has at the end of its robotic arm, it has two absolutely state-of-the-art instruments called Sherlock and Pixel. As a reminder, Sherlock is a UV spectrometer, and Pixel is an X-ray analytical tool. And the distinction between these both is that Sherlock, as a spectroscopy tool, will be able to provide details of compositions of the samples itself, but it might not tell us how those chemicals are distributed. Whereas Pixel is actually almost the opposite. It might not be able to provide us with exact chemical information, but it will be able to tell us how these chemicals are located within the rock structure. And a lot of the news lately has been from the Sherlock instrument. As you can see here, this was taken before, of course, the rover went to Mars, and Sherlock has been detecting a lot of organic compounds on the Martian floor. And as you can see here, there's been quite a few reports or papers being published in the last few days about Sherlock being able to detect organic geochemistry in Jezero. Now, all this to say that the media has been, of course, getting all excited again. Organic chemistry, let's not forget that organic chemistry doesn't mean there's life. It's just the building blocks that life needs in order to arise and evolve. So we're just found some building blocks once again on Mars. It's not the first time, and it won't be the last time. These are some of the extracts of the scientific paper where we see images from Sherlock and Pixel and other instruments on the rover, detailing with great clarity the discovery of these organics. But I'd like to remind our viewers and everyone on this panel that we've also found a lot of olivine on the crater floor, and olivine is a mineral that reacts very well with water. And unfortunately, the discovery of the discovery of olivine on the crater floor implies that even though we do believe that those deltas that I showed you in the beginning are, of course, the process of water, and there has been water coming into this lake, it seems that as far as it goes for now, it seems like there was just not enough water to make Jezero crater become a proper lake that would last for a long time. We have not seen any sedimentary rocks within the crater floor itself where the rover landed, but instead we have detected quite a lot of olivine. So it does seem that if there has been water, and of course there has been water, but we do now think that there might just not be enough water for to have a sort of a proper lake environment where life could arise and evolve for millions of years. So I just wanted to remind our viewers that within all the hype that the media surrounds with Mars and the organics and all that, let's just not forget that we have another part of this amazing Martian science, and that's trying to carry on understanding how water evolved on the planet, and where can we find better traces of water and organics at the same time in order to generate life. So it might seem like, while Jezero Crater might have looked like a fascinating target, it might seem that it might not be such an amazing target after all. Of course, all this is to put in conditional. We're still exploring this crater. Maybe we just haven't discovered. Maybe the sedimentary layers on the crater floor have been, eroded with the wind and such not. And of course, the rover is also starting to explore sedimentary layers within the delta itself, and that's going to be really exciting. But I just wanted to remind everyone that Mars is a complicated place, and it's not as simple as what the media is trying to portray. So there you go.
Fantastic. Thank you so much. That's wonderful. Okay, wonderful. Incidentally, let me just kill that for you.
Oh yes. So this last slide, I just wanted to show. This was from a news media outlet, and this is what we thought Jezero Crater was looking like in the past before the rover landed. But now we most likely believe that this is probably not how the crater was. It was not filled with vast quantities of water. It was most likely, very little water would come in, and then it would freeze, and then you would have really, salty brines coming in, but it would never look, as fantastic as it looks there, like full up.
Yeah. So it was more sort of isolated pools of water rather than a lake, probably.
Yes, that's how it's looking like for now. Of course, maybe in a year, the rover will discover, evidence.
Absolutely. Great, thank you for that, Bernard. And while we are talking on the subject of olivine, just happen to have a lump of olivine here, which, as you can see, is very green in colour, hence its name. And this one, I don't know whether you can see that, it's incredibly pockmarked. This came from a volcanic eruption. I went on an expedition up into the mountains, into the forest, to visit the site of a phreatic eruption, one involving water, that had happened a few million years ago at least. And there's lumps of olivine just lying around everywhere. And I quite like this specimen because you can see that the gas that was in the rock has sort of bubbled out, as it were. And there we are. That's part of my local collection of volcanic goodies. So there we are. Okay, where are we next?
Yeah, so there we go. Anyone else has any comments, questions, or anything related to this? No. Okay. Someone mentioned on the chat that, is Mars actually green then? No, of course. We all know it's still the red planet. Nevertheless, aliens are green, so who knows?
Who knows? Who knows?
Mary, I believe it's your turn now. You would like to talk to us about what was it again about? I forgot. So you go ahead.
Last Thursday, I visited Basingstoke Astronomical Society, and I did a half-hour talk about my own sketching and art that I do. I do astronomy sketching, but also kind of astronomy-inspired art. And in the second half, everybody was pushed out of their comfort zone, and I took them through step by step to create a sketch of the photograph you can see in the white box on the bottom right of this picture. So this is crater Archimedes, and a couple of people did it in pencil, but primarily we were working on black paper with pastels, which is my favorite. And everybody did such an amazing job. And I love seeing collages like this because I think I explained to them that nobody's sketch will ever look like mine or anybody else's. If I got every person in that room to write out a verse from Shakespeare, no two handwritings would look the same, but it would all still ultimately be Shakespeare. Same thing with drawing. If you the way you hold your pencil, how much tension you've got in your shoulders, it will all make a difference to how you draw. But it's really clear that every one of these pictures is Archimedes. It's so cool. So yeah, I just wanted to show that they all did such an amazing job, and it really makes me happy when I put these collages together.
They are very good, aren't they?
They
And
did amazing.
I believe we're going to be doing, or you're going to be doing, a live sketching workshop here on Space Oddities, Mary.
Yes, I'd really like to do that. I've had quite a few people ask me if we can do it. So if any of you guys are up for it as well, let us know in the comments if that is something that you want. Because yeah, I'm optimized it for working online, so we can use stuff that you'll already have at home. And so if there's an interest for me to do that with you all, then yeah, I'm more than happy to do that.
Fantastic.
I'd be interested. Mary, I'd be interested.
Excellent.
Yeah, and count me out on that one. I'm afraid I can't even draw the curtains. So
you don't need to draw the curtains. You need to draw a crater.
I might give
No,
it
but
a go.
honestly, Andy, everybody says, like, who comes to my workshops, oh, I can't draw, I'm going to sit it out. And then they come out with something like this. It's about following the simple steps. And once you've done it once, you'll find it easier next time. And even if you only try it once, it will fully make you a better observer, because you have to really look at something to draw it. So, and it's one of my favorite things to teach. I love doing sketching workshops. So.
Yeah, and you're very good at it as well. And I bet a lot of the people there really surprised themselves, didn't they?
Yeah, and one of the things that when you're looking down at it and you've been working on it, all you see is the flaws. But I will take that off people and just go 6 feet away holding it up, and then suddenly you see their face change. It's like, oh, did I just draw that? When you're just looking down at it the way you've been drawing it, you don't see it in the same way. So if you take a photograph of it on your phone and look at it on the screen, you will see it with different eyes. And it's just amazing what you can produce, even if you've been told by your art teacher that you're rubbish at drawing, which has happened quite a few times. So I know people come to me and say, my art teacher said I was rubbish, I've never drawn since. And then they do these amazing sketches that look like photographs. And so everybody can do this.
Fantastic. And this will be a special edition of Space Oddities. We won't try and incorporate it into this normal Monday program. We'll do it as a special edition. Were you saying you'd like to do that in the new year, Mary?
Yeah, my schedule's slightly crazy for the end of the year, but in the new year, it'd be great to do that.
Okay, well, we're getting lots of positive reactions, as you can see here. So I think you're going to have some takers there.
Excellent.
So God, even Daz says yes, please. So, so there we are. Ian says,
if Daz can do
couldn't tell
it.
which was the photo. Look. And yeah, we got some lovely comments coming in. So I think that's going to be a hit, Mary. So we'd love you to do that, and thank you very much.
Yeah, absolutely. And I was going to say, can do it. I think pretty much anyone can do it, really.
Yeah.
Thanks, Mary. It's wonderful. Absolutely wonderful. I'm looking forward to it. Absolutely.
Yeah.
Andy, you wanted to talk to us about competition and calendars.
Yes. Firstly, a big thank you, and I mean this from all of us, for those of you who have already purchased your 2023 Space Oddities calendar. And we are really grateful to you for doing that, because we think they're ideal Christmas presents. So I'm just going to, before I get onto the calendar, I'm going to go through the just to remind you about the monthly competition, the November competition that we still have going on. So let's just give you a reminder about this. It's to win these two lovely sets of binoculars, one suitable for a child or a beginner, the other one a pair of 10x50s suitable for an adult. And what we ask you to do for this, well, let's have a look. Here's the Helios Sport 10x25s. and the Helios 10 by 50s. As we all know, Helios make exceptionally good lenses. So well worth having. One lucky person is going to win both of these sets of binoculars. And what we would like you to do is this. The competition is aimed at families where one adult and one child can participate. With Christmas coming up, we thought we'd like to make it more of a family thing, with a child and an adult both winning binoculars. And what we would like you to do is to write a short poem, up to 200 words or thereabouts, about any astronomical object, anything that takes your fancy. Now, we've been discussing this week, and we haven't had any entries for the competition yet. And this is a tiny bit worrying to us, because we do want somebody to win these prizes. So we're going to extend this to include not just poems, but any prose, any length of text. So if you want to write a few paragraphs about your favorite astronomical object and why it's your favorite astronomical object, and then, or you can write a poem, as we said, then the child of the family up to the age of 15 should then create a drawing or a painting to illustrate your prose or your poem. The poem can be in any style, can be freestyle, can rhyme, can go to Shakespearean lengths of rhyme. It can even be a limerick, and there are actually quite a few good astronomical limericks out there. My favourite one is, there was a young man called Bright who travelled much faster than light. He set out one day in a relative way and returned on the previous night. So that's my favourite one. But if you want to write an astronomical limerick, that's great, and get a child to illustrate it. And the child can do the drawing or the image in any medium, including computer graphics, if they want to knock something up on the computer. Please send your poem and the image to us at spaceodditieslive@gmail.com. Please, it needs to arrive no later than the end of Friday, the 9th of December. That'll give us the weekend to judge the winner, and we will be announcing the winner on the Monday, the 12th of December's program. So there we are. Please include your home address in the email. Very important. We do need to know where to send the binoculars. And the entry that the Space Oddities panel liked the most will win. That's the combination of the text and the image, of course. Panel's decision is final, as you would expect. And if you enter the competition, you are giving us consent to use the poem, the text, and or the image in promotional, that is to say, not commercial purposes. So put your quill in your bottle of ink and start writing about perhaps an astronomical object. Doesn't have to be your favourite one, but if you want to write up to 200 words, poem, or just straight text about an astronomical object, then and get a child to illustrate it, that's the competition this month. Right. Okay, now moving on to the calendar. As I said, thank you very much to everybody for who has already bought the calendars. They are available to UK and ERA residents for £8 sterling, including postage and packing. Please pay us via PayPal at the address spaceodditieslive@gmail.com, our normal email address. The name will appear as Darrell Salisbury when you do that, because Daz set the account up, so you'll get Daz's real name coming up there. And let's hope that Interpol don't find out about that. And then send us an email to the same address, spaceodditieslive@gmail.com, to confirm you made payment, and give us your home address to send the calendar or calendars to. Now, if you have any trouble paying via PayPal, because technically you don't need a PayPal account to send money via PayPal, but some people are saying they're having trouble doing that. If you have trouble and you can't use PayPal, send us an email, tell us about it, and we will tell you of an alternative way to make the payment. They are ideal Christmas presents, and I'm now pleased to premiere the actual calendar itself. And here it is. So this is the Space Oddities 2023 calendar. This is hot off the press. This is what we got from the printers, and it's just a compilation, really. So we have the, hang on, let's go back a bit. So we have the Andromeda Galaxy by Lee Hoare. We have The Sol Nebula by Andy Weller. The Moon by Tom McCrory. Sorry, Tom, stumbling there. The Partial Solar Eclipse by Sonia Turkington. That lovely image with the plane in it. The Horsehead Nebula by Arnau. And Arnau, we couldn't decipher your surname, unfortunately. We did send an email to you, but we didn't get a reply. So I'm afraid you are in the calendar, but only with your first name. And that's a lovely image of the Horsehead. Liho's negative or reversed image of the moon, which everybody liked very much. We have Chris's The Heart Nebula. Jerry's Inside the Soul Nebula. We have Kevin Earp's The Moon, which is lovely, as ever, Kev. Grasshome Observatory, or taken from Grasshome Observatory in the foreground there, by Andrew Moore. Jerry again with the Eastern Veil Nebula. And then lastly, Michael with Aiguille du Midi in Chamonix in France. So those are your images for the calendar. This is what you'll be getting in a calendar format, and they do really make inexpensive, ideal Christmas presents for somebody. So get with the process and get your orders in. Book now to avoid disappointment, as they say.
Yeah, there's a lot of Royal Mail strikes, so bear that in mind. Don't leave it till the last minute to order one.
No, I wasn't aware of that, but thank you, Mary. So yes, and that's about it. And don't forget what I said about the competition. We're not limiting it to poetry now. Up to 200 words on any astronomical object, and you and your child could win those gorgeous Helios binoculars. And good luck, everybody.
Thank you, Andy. And as a reminder, watching the night sky with binoculars is as amazing as watching the night sky with telescopes. So I'm very jealous of the person who's going to be able to share those binoculars with their children. Andy, since you're there, Chris said he ordered and paid the calendars last week, but haven't heard anything since. I presume maybe we'll need to come back to Chris at some point.
Right, Chris. Yes, well, the calendar is at the printers at the moment, and we're expecting to take delivery of them within the next week. And as soon as they arrive, we will, of course, send them out. So
Fantastic.
It's being printed even as we speak. We had a little bit of a delay with it because of the way that the printer wanted us to submit the images, and it was all about scaling factors and distortion and Daz and I have spent an incredible amount of hours this week trying to sort out the problems, getting the calendar perfect for ready for publication. But we got there in the end, and we have to say that the printers concerned were very helpful, and they sorted out the problems for us. But Anne says, is an aunt and nephew allowed as family in the competition? Yes, of course, Anne. Of course, that's family. So no problem at all. And good luck with that. And hope you're all well in Ireland, Anne. And looking forward to seeing you soon.
There we go, folks. Worry, everything's in good hands. Right, I believe we're slowly arriving at the end of this session. Thank you so much for watching. Don't forget to subscribe and to like us and to mention us to your friends and family around, because this is the only way this channel is going to keep on growing. We'd like to thank again our really cool sponsors, Rother Valley Optics, for supporting us and helping us doing these competitions and making people enjoy space and the night sky. I'd like to thank as well our panelists here. Thank you so much. It's been a great show, and we hope to see all of you again once again next week on Monday at 8 p.m. UK. Sorry, Andy?
Thank you. And can I just reiterate that your subscriptions are really important to us, because they do help us to grow. They help the YouTube algorithm to notice us and further publicize our videos. So please, if you haven't subscribed yet to the channel, please consider doing so. Only takes a second. Just hit the subscribe button. It doesn't cost anything. and you'll get notified of everything that's going on. What more could you possibly want out of life?
Very good, very well. And on this great note, I will say goodbye to our viewers and everyone at the panel. Goodbye, everyone.
Bye.
Thanks for watching.
Bye, everyone.
See you again soon. Bye bye.
Bye.
Thank you for
Bye.
watching.
Bye.